All right, we were doing number 20 or 41 on page 266 when we ran out of time on the last video. So this box is 25.5 kilograms and a mover is pushing it with a force of 85 newtons. So F is equal to 85 newtons down a 15-meter long corridor, so delta D is 15 meters. And it tells us that it takes him 8.3 seconds to do this. And it wants to know what is the power. So power is equal to work over time. And work is equal to F delta D cos theta over time. So the F is the 85 newtons. The delta D is the 15 meters. And if you look at the two arrows, the angle is going to be 0 degrees, so cos of theta is going to be 1. And the time is 8.3 seconds. So power is going to be equal to 153.6 joules per second, which is a watt. Okay, so that's number 41. Number 42, a chairlift. Sorry, just trying to find the edge of my paper. A chairlift carries skiers uphill to the top of a ski run. The lift is able to do, and it's going to give us work, 1.85 times 10 to the 5th joules of work in 12 seconds. Delta T is 12 seconds, and the question wants to know what's the power. So power is equal to work over time. So 1.85 times 10 to the 5th joules divided by 12 seconds. Power is equal to 115,416 point, I think it's 6 repeating, watts. Okay? And then it says in both watts and horsepower. So now at the end of class I had told you that 1 horsepower, which is the empirical unit, is equal to 746 watts. So if you have 15,416 watts, how many horsepower is that? So you would take your 15,416.6 repeating and divide it by 746 watts per horsepower. And when you do that, the watts will cancel, the horsepower will end up on top, and you get 20.66 horsepower. Okay? Number 43 says a 75 kilogram student, so we have a mass of 75 kilograms, runs up 2 flights of stairs in order to reach her next class. The total height of the stairs, okay, so she's going up these stairs, and the height here is 5.75 meters. If the student can generate 200 watts of power and has 20 seconds to reach her class at the top of the stairs, will the student be on time? So the time is 20 seconds. Okay, so we can find the work done because this is like the student, the force she's applying has to be a force equal to her mass, right? Because Fg is going down, so really she's lifting her mass up these stairs, and so she's lifting them a height of, so your delta D here is 5.75 meters. The horizontal distance doesn't matter because it's not going in the same direction as the force. So the force and the delta D are both going this way. Okay, and so we can find the work done. It's equal to F delta D cos theta, where the cos theta will be 1. And the F will be mass times gravity. So the work done will be 75 kilograms times 9.81 meters per second squared times 5.75 meters. So W here will be equal to, I don't think I typed it out, and I don't know where my calculator is. There it is. All right, so 75 times 9.81 times 5.75. So the kid's doing 4,230.5625 joules of work. And it says she can generate 200 watts. So we know power is equal to work over time. So time will be equal to work over power. So the 4,230.5625 joules divided by the 200 watts she's able to generate will tell us how long it's going to take her to get there. And when you do this, you get a time of 21.15 seconds. Unfortunately, the bell is going to ring in 20 seconds, so she cannot make it on time. She's going to be just a little bit late. Not a lot late, but a little bit. Okay? And that's the last question from your homework.